SwayamPrabha. Digital India. Educated India.
Good morning, students. Now you must be seeing a change. We are no more inside the classroom. We are free in open space. That is the beauty of aeronautical or aerospace engineering, that you have infinite liberty to conquer the atmosphere. You could see at present, we are all standing here on the tarmac, and with me Mr. Vipul Mathur, who is the chief engineer here, and with my team members help us in maintenance. They are the lifeline of Flight Laboratory IIT Kanpur, and that is how we could manage all these aircraft and impart training courses in terms of academic enrichment to many colleges, including IITs and all government-sponsored colleges, private-sponsored colleges. If you recall, in the class, I have discussed a little bit about stall speed, like the minimum speed of the aircraft, where it can maintain lift equal to weight. We have also spoken about the importance of speed. And in that connection, we were very emphatic about it, that we need to understand how a pilot gets the feel about the air speed, which is the air relative speed, and hence we will be giving a lot of weightage on instruments, on the measuring instruments, namely airspeed indicator and the altitude, which is altimeter, which gives the pressure altitude. Please understand, before an airplane goes for a takeoff, this tarmac is the most important place where the engineer first checks the plane. He will be doing the run-up for the engine, and after doing all checks, he will be releasing the aircraft to the pilot. Then pilot does his own preliminary check and then goes for the preparation for a takeoff. Today, I have requested Mr. Vipul Mathur, who is the chief engineer, to explain what are the procedure for preparing for a takeoff. So this part, you must try to understand what are the methods, what are the procedures to be followed to ensure that you are ready for a takeoff. And at the same time, I have requested him to explain you about the airspeed indicator, altimeter and other instruments, so that you get a better feel. And from here, we'll go back to the classroom and again start writing equations to see that yes, a designer has given enough bandwidth in the design so that the pilot can fly very comfortably. Thank you very much.
Good morning, I'm Vipul Mathur, Chief Engineer IIT Kanpur. At the moment, we are inside Piper Saratoga aircraft. This is the cockpit area where we are sitting. This is the instrument panel of this aircraft. You can see the two controls. This is the control stick. You can compare this control stick with the handle of your cycle. When you move the handle of your cycle on the left side, like this, your cycle moves to left. Similarly, in this aircraft also, when you move the handle to left, your aircraft banks to left. When you move the control stick to right, your aircraft banks to right. Then we have the engine controls. This is the throttle control. The more the throttle you give, the more the engine generates power. This is your propeller control. With the help of this control, you can vary the blade angle of the propeller, and this is your mixture control. With this control, you can vary the mixture of fuel and air going inside the engine cylinders. Now, this is your switch panel. You can see we have different switches. This is your master switch, and there are various other switches here. You can see all these white switches. These are the switches. These are all the circuit breakers. You can see this is the circuit breaker panel. This is your radio sets. These are your radio sets. We have KX165, Bandix King KX165 radio set in this. This is your altimeter, which indicates the altitude at which you are flying. This is your airspeed indicator, which gives you the indicated airspeed at which the aircraft is flying. This is your vertical speed indicator, which gives you the rate at which you are ascending or descending. This is your RPM gauge, which gives you the RPM of the propeller. This particular aircraft, the maximum RPM is 2700. Then this is your exhaust gas temperature gauge, which gives you the temperature of the exhaust gases coming in the cylinders. You can see this gauge, there are 3 gauges in one: oil temperature, cylinder temperature and oil pressure. This is the fuel quantity gauge, One for the left tank, we have this left gauge. For the right tank, we have the right gauge. The two tanks are in the two wings. We are going to start this aircraft. Before starting this aircraft, inside the cockpit, the very first thing we need to ensure is that your parking brakes are on. This is the parking brake, and in order to ensure that your parking brake is on, you have to brake and you press your rudder pedals and then push this lever back, and the parking brake is on now. This is the ignition switch of the plane. This is the key of this plane. This is the ignition switch. I am putting this key inside the switch. A few settings in this. This is the off position of the switch, and this is the start position of the switch. So now, apart from these two positions, we have got both left and right. So this I will explain you while I will be doing the ground run, the significance of these three positions, both left and right. In order to start the aircraft, we have to put the master switch on. This is your master switch. Now I've put this master switch on. As you have seen, when we put the switch on, the electrical power is on the aircraft. So with this master switch on, now I need to prime the engine before starting. So you can see here there is a fuel pump switch here, which at the moment is in the off position. Now I will put this fuel pump switch in the on position. You can listen the sound of the fuel pump, and I'm putting this mixture control in the rich position. Now with this procedure, I have primed the engine. With the engine primed now, I'm going to start the engine. Now you can look at this ignition key. At the moment it is in the off position. Now I'm going to put it in the start position, and now I will put the key to the start position. That is, I will try to engage the starter, and the prop will start moving. You can see as you have seen, I have engaged the starter, and now the ignition key is on the both position. As soon as the engine fired, I have put the mixture control to the rich position. In the mixture control, there are two positions. This is your lean position, and this is your rich position. Rich position means your maximum amount of fuel is going inside the engine cylinders. As soon as your engine starts, you can see the propellers moving in the front, although you will not be able to make out because the RPM is quite high. Now, when the engine has started, you can see the propeller moving outside, although you will not be able to see the propellers at the moment because the RPM is quite high, almost around 1200 RPM. As I had told you earlier, this is your temperature gauge and this is your oil pressure gauge. The very first thing you need to observe when starting, just after starting, that your oil pressure should register within 30 seconds. So as soon as we started, the oil pressure gauge needle has come to the green range, it has registered. In case if the oil pressure needle does not register, then you have to switch off the engine. That indicates your oil pressure is nil, that is, your oil has not started circulating in the system. So with the oil pressure needle registered, this indicates that your oil pressure, that your oil is circulating in the system. So with this, as you have seen that oil pressure has already registered. Now the aircraft is on 1200 RPMs. You can see this is 1000, this is one graduation is 100, and another graduation, this is 1200. So the propeller is moving at 1200 RPM. I will run the engine for some time and see that the oil temperature has registered in the green range and the cylinder temperature is also in the green range, so that the engine temperatures have come up to the operating levels. So now we will wait for some time for the temperatures to come to the green range. Now you can see your oil temperature is already in the green range. Your cylinder temperature, that is the cylinder head temperature, is also in the green range. Your oil pressure is also in the green range. Now we will move the throttle. This is the throttle lever. We will move the throttle lever and take it to 2000 RPM. From this position, I am going to take the throttle to 2000 RPM. Here you can see this is the 2000 RPM. You can see 2020 written. That means this is 2000 RPM. After reaching 2000 RPM, I will move this propeller control lever. This propeller control lever, you can see there are two settings. This is the top setting is the fine pitch. This is the coarse pitch. So at the moment, the propeller is on the fine pitch. At 2000 RPM, I will move this lever to the coarse pitch, that is to the down position, and check whether there is a drop in RPM or not. So here we go now. I am moving the propeller RPM to 2000. At the moment it is 1200. Now we are moving to 2000. So you can see gradually, you can listen the sound of the engine. The engine sound has started increasing because we have started moving the throttle upwards. Now it is at 1500 RPM. We are gradually moving up. You can see now we have come to 1600. We are now on 1700. It is 1800 now. It is 1900 now. We are just 100 short of 2000. Just see that the needle is gradually moving towards 2000. Now you can see your propeller RPM is at 2000. As I have told you earlier, with the prop RPM at 2000, I will turn this lever to the coarse pitch. This is the coarse pitch. I will put this lever down. You can listen the variation in the sound of the propeller because the propeller is now moving from fine pitch to coarse pitch. In addition to this difference in sound, you will see the drop in RPM. The check what we have to do at the moment is we need to observe that the drop should not be more than 500. So just now watch out. I am moving this lever to the coarse pitch. See, this lever has gone to the coarse pitch. And you can see, you have listened the variation in propeller. Just see it again. I'll show it once more. Just observe the drop in RPM. This is 2000 at the moment. It should be less than 500. Just observe that it was something around 300, 350. So this was all about the propeller check. Now with the propeller RPM at 2000, I will further move towards the full throttle. That is, as I have told you earlier, full throttle RPM is 2700 in this particular plane. When we reach the full RPM, the thing which we have to observe is the manifold pressure. You can see this is the manifold pressure. Manifold pressure with full RPM should be something around 29 inches of mercury, which if the engine is able to generate that much of manifold pressure, that means your engine is developing power up to its requirements. Whatever engine is designed for, the engine is generating that much of power. So just observe that I am moving the throttle to full RPM, that is 2700 now. See, RPM needle is gradually moving. It is now at 2200. Now when we are moving towards the higher RPM, we need to ensure that our brakes are on. You can observe that in addition to the parking brakes, our feet are on the brakes, because we need to ensure that the airplane should not move forward, although the parking chokes are already on. Now just watch the propeller RPM. The RPM gauge needle is moving to 2500. You can see the manifold pressure gauge is around 24 at the moment. Just watch out. This is moving to 26. You can listen the sound of the engine. See that it is almost 2700. We are at full throttle and see the manifold is at 29. Plus, we need to ensure all your temperatures are in the green range. Oil temperature, cylinder temperature and oil pressure. Now I am gradually moving backwards. I am reducing power now. You can see the needle is now moving backwards because I am reducing power. You can listen the engine sound also. Gradually it is coming down. So now we are back to 2000. Now from here, from 2000, I will move the RPM to 1700. At 1700 RPM, I am going to check the ignition system, the ignition check. I have told you earlier that the ignition switch has got 5 positions: off, right, left, both and start. At the moment, the ignition switch is on the both position. You can see the ignition key is on the both position. Now at 1700 RPM, I will move this key from both to right position and observe a drop in RPM. After observing the drop, it should not be more than 125 RPM. After observing the drop, I will move the ignition key from right to both position. And similarly, we will check the ignition system for the left position also and move the key from the both position to left position. Now watch out. I am moving the propeller RPM from 2000 to 1700. Just watch out. I am at 1800 at the moment. It is now 1700. Just look at the needle. It is at 1700. Now watch out this ignition switch. It is the key is at both position. From both position I am moving to right position. And you can observe the drop. ये दोनों cover करना है. See, it is from both to right. See the drop. You have seen from 1700 it came to 1600 and is back to 1700 because the ignition key was switched to both position again. So what we observed a drop of around 100 RPM, which is satisfactory within the range. Now I will put the ignition key from both to left position and we will again observe the drop. Again, the drop in RPM was around 100. So we have checked the ignition system. Now we will reduce the RPM again. See, gradually I am reducing power. needle is coming back and we are approaching 1000 RPM. You can see the needle is at 1000 RPM. Now with this 1000 RPM, I will move the throttle lever to the idle position. You can see this is the full throttle setting and this is your idle position, just the extreme. So now the throttle is at idle and this is your idle RPM, something around 800, 850. And I will check the mixture also. Now to check the mixture, I will put the mixture control from rich position to the lean position gradually, and the increase in RPM should not be more than 20-25. So just see that I'm gradually moving the mixture control lever from rich position to the lean position, and you can see there is an increase in RPM of around 25. I have again moved the mixture control lever back to rich position, just in order to ensure that the engine doesn't cut off. Now with this, we have checked the full power being generated by the engine, we have checked the ignition system, we have checked the propeller system, we have checked the mixture system, and now we will taxi the aircraft. We will show how the aircraft is taxied and how do we turn the plane on the ground. As we had put the parking brakes on earlier, now before going out for taxiing, we will ask the people outside to remove the ground chokes so that we are clear to move out. I am indicating them to move out the chokes. So the people outside have removed the chokes. I'm taking the clearance from them. They are indicating me thumbs up. That means both the chokes have been moved out. Now I'm moving the parking brake out. You can see that now the parking brake is also removed. Chokes are also out. Now I will move the throttle forward. That means I will generate some more power and we will start taxiing. Process, I have checked the brakes also. I'm putting the brakes. The aircraft is stationary now. You can see. I have checked the brakes also, the functioning of the brakes. Now I will turn the aircraft to left. Both the pedals are at the same level, that is at the neutral position. See, the left pedal is moving inside. The aircraft is turning to left. The aircraft is turning to left. You can see that. Now the right rudder pedal is going inside and the left is coming out. Now both the pedals are again in the neutral position and the aircraft is moving straight. You can see that both the pedals are there at the same position, almost at the neutral position, and you can see outside. Now you can see that the aircraft is moving straight with both pedals in the neutral position. Now I would like to show you how the aircraft is turning to right. Just see that right rudder pedal has gone inside. You can see outside the plane. Just watch out. The plane is turning right on the ground. Now we are moving back to the tarmac position. I'm applying brakes now. I'll put the parking brakes again now. Still, I'll keep the brakes on, and before shutting off, I'll clear off the engine. I'll I'll keep the propeller RPM to 1200 for a few minutes for the temperatures to stabilize. And finally, I will switch off the engine. So how do we switch off the engine? This is your mixture control. I've told you earlier that this is your rich position. Most forward position is the rich position. Most backward position is the lean position. When we put the mixture control to the most backward position, that means we are cutting off the fuel supply to the engine cylinders. When there is no fuel supply to the engine cylinders, engine shuts off. So this is what I'm going to do. I am moving this mixture control lever from the rich position to the idle cutoff position, that is to the most lean position, and just see, the engine has cut off now. You can observe now the engine has stopped. Now we are sitting in a modern cockpit, which is also called a glass cockpit. This aircraft is Cessna 206H, newly inducted in Flight Laboratory IIT Kanpur. This aircraft has got Garmin 1000 avionics. As you can see, there are two screens in the front. This is the first screen called the PFD, that is the primary functional display. This is the second screen, which is called the MFD, which we call as multifunctional display. So whatever gauges we have seen in a conventional cockpit, there were all analog gauges. In this cockpit, we have all digital gauges. Here you can see that on the top left corner is the nav box, we call the navigation box. On the top right corner is the communication box. So whatever navigation settings were required in that conventional cockpit are given here. This on the left side, and here communication on the right side. On the left side of the panel, you can see we have all the engine gauges. You can see all digital gauges. On the left side, these are all the engine gauges. Right on the top is the manifold pressure. You can see this is the manifold pressure. Second place, this is the RPM of the propeller. You can see the markings given: green marking, red marking, white marking. Then third is the fuel flow indicator, which gives the fuel flow in gallons per hour. You can see as we start the engine, this bug here moves to the right and indicates the fuel flow. Next is the oil pressure gauge. Here you can see in the red light, this is blinking, red light blinking, because at the moment engine is not on. So that's why red light is blinking, oil pressure is blinking. So here we can observe the oil pressure. Next is the oil temperature gauge. This is the oil temperature. Again, you can see a bug here. When the temperature increases, this bug moves and goes to the green range. You can see the green range, and at the end you can see a red line also, which indicates the never exceed range. Then next is the cylinder head temperature gauge. This is the CHT gauge. After that is the EGT gauge, that is the exhaust gas temperature gauge. Next we have the fuel quantity gauge. You can see here there are two bugs here, one on the top, one on the right. One indicates the left tank, one indicates the right tank. On the top bug, it is L written. You can see that L is written here. On the yellow, this indicates the left tank. On the bottom bug is R written, which indicates the fuel quantity in the right tank. These are the electrical instruments. This gives you the bus voltage and then the battery amperage. This was about the engine instruments. Here in the conventional cockpit, you saw the altimeter, the airspeed indicator. In this cockpit, you can see this is the altimeter. This indicates the altitude at which you are flying, and this gives you the specific altitude at which you are flying. And this is the scale. This is the pressure that is to be set in the altimeter. You saw in the conventional cockpit that it was to be set in the Coltsman window. Here, this is the place where the pressure has to be set. Then this is the airspeed indicator. We have already seen the conventional airspeed indicator in the conventional cockpit. As a standby instrument in this cockpit also, you can observe conventional analog airspeed indicator and altimeter, which are provided as standby instruments in addition to the digital instrument. So on the left side you can see this is the airspeed indicator. At the bottom we can get a true airspeed also here. Just next to the altimeter is the vertical speed indicator or the rate of climb indicator. Now we have a few navigation instruments. This is your attitude indicator. This is your horizontal situation indicator. That is we call it HSI. Here in a small window you can see it gives you the outside air temperature, the OAT. As you can see, the two screens are displaying the same data. The PFD as well as the MFD, they are showing the same data. But we can change the display on the MFD, that is on the second screen on the multifunctional display. We can change the display, and you can see here we are getting the navigational maps. So while flying, basic airspeed, altimeter, vertical speed, your artificial horizon, your HSI, all these data, your nav data and your COM data, this you are getting on the first screen, that is on the PFD. On the MFD, you are getting the engine instruments as well as the navigation maps. So lot of data has been distributed within these two screens. So you can see that the efficiency of the cockpit has increased because of this glass cockpit as compared to the conventional cockpit. The space required is very less. All the data has been squeezed in these two screens, and it is very reliable as compared to the other cockpits. Thank you.